So we are going to go over take-home problem 5. So let's check answers to take-home problem 5. An urn contains 2 red balls and 3 blue balls. Balls are drawn one after the other and without replacement. Let X be the number of blue balls. Construct a probability distribution for X. Find the mean, variance, and standard deviation. So the first task here is to construct a probability distribution for X. We want to determine the possible outcome in this random experiment. We could get boy, or there the first time. I'm sorry, blue or red the first time. Second time blue or red. Second time blue or red. So what is the probability that we get blue the first time? Pardon? How many blues? How many blue balls? 3/5. And here, 2/5. Now, if the first is blue and we do not replace it, what is the probability that the second will be blue? Just the same as 1/2. And if the first is red, what is the probability that the second is blue? 3/4. Because we do not return, so the number of balls have reduced to 4. So outcome here is blue, blue, with probability 3/5 times 2/4, which is, let's just say 3/5 times 1/2, which is 3/10. This outcome is blue, red, and the probability is 3/2 times 1/2. This outcome is red, blue, with probability 2/5 times 3/4 is 6/20, which is also 6/20, 3/10. Red, which is 2/5 times 1/4. So that will give us 2/20, which is 1/10. So having these probabilities, we can see that outcome with 0 blue is red, which has probability 1/10. Outcome with exactly 1 blue are blue, red, or red, blue is one of the two that will provide us with an outcome with exactly 1 blue. So we will add 3/10 to 3/10 to get 6/10. And then 2 blue will be blue, blue, which is only 1. The probability is 3/10. So we have our probability distribution here. This is the probability distribution. And we can find the mean, the variance, and the standard deviation of this distribution. To find the mean, we take each value and multiply it by the probability. So 0 times 1/10, plus 1 times 6/10, plus 2 times 3/10. That gives us 6/10 plus 6/10 equals to 12/10, which is 6/5 equals to 1/2. 1.2, I'm sorry. 6 divided by 5 equals to 1.2. So the mean is 1.2. To compute the variance, we need the mean of the square, which is E of x squared. That's obtained by squaring each value and multiply by the probability. So we square 0 and multiply by 1/10. We square 1 and multiply by 6/10. We square 2 to get 4 times 3/10. So we end up with 6/10 plus 12/10, which is 18/10, equals to 1.8. So the mean of the square of x is 1.8. The variance is mean of the square minus square of the mean. E of x squared minus E of x squared. If I'm reading it that way, it will sound like the same thing. Expectation of the square minus square of the expectation. That is 1.8 minus 1.2 square equal to 0.36. Sigma equals to 0.6. 0.6 is the square root of 0.36. Any questions so far about this? Okay. I'm going to put this on Canvas at the end, these answers. So. An insurance company insures a person's antique coin collection worth $20,000 for an annual premium of $250 if the company figures out that the probability of the collection being stolen is 0.02. What is the company's expected profit?
what is the company's expected profit. So we use the rule that profit equals to revenue minus cost, and identifying the random variables involved in this. The revenue here is the money you get. How much money do the insurance company get in this business? Yes? How much money is the insurance company getting? Pardon? $250. That's what we call the premium in insurance. It's the fixed amount of money you pay the company. It's not a random value, it is a constant. Now, in this business, what will it cost the insurance company to conduct this business? The cost now is a variable because it depends on whether the coin is stolen or not. If the coin is stolen, the company spends $20,000. So sometimes I like using the revenue, using the random variable involved in the relation rather than doing the computation all through, that is finding the random variable of the profit. Using the linear property of expectation, we will see that R is a constant and C is a random variable. C is a random variable that will be 20,000 if the coin is lost with a probability of 0.02, or 0 if the coin is not lost with a probability of 0.998. So the expected cost here will be 20,000 times 0.002 plus 0 times 0.998, which is 40. So the expected cost in this business to the company is $40. So the expected revenue, the expected profit is expected revenue. Revenue is constant, $250, minus expected cost, $40, which is $210. So the expected profit in this business is $210. Any question about this? Exercise 2. Let x and y be two random variables with mean of x equals to 130, standard deviation of x equals to 6, mean of y equals to 120, and standard deviation of y equals to 5. Let L be 2x minus 200 and W 3x minus 2y. Find the mean, variance, and standard deviation of L. So this is a linear transformation. L is a linear transformation. L is 2 mean of x minus 200, which is 260 minus 200. So we have 60. The variance of L is variance of 2x minus 200, which is equal to 2 squared times variance of x. The variance of a constant is always 0. So that gives us 2 squared times 6 squared, which is 4 times 36, equals to 144. And the standard deviation is the square root of 144, which is 12. B, find the mean, variance, and standard deviation of W. The mean of W will be 3 mean of X minus 2 mean of Y, which is 3 times 130 minus 2 times 120, which is 390 minus 240 equals to 150. And the variance of W is variance of 3X minus 2Y, which is 3 square variance of X plus minus 2 square variance of Y. This is 9 times variance of X plus 4 times variance of Y, which end up being 324 plus 100 equals to 424. And the standard deviation is the square root of the variance, which is 20.6. The last question here, the US Department of Health and Human Services report that 7% of Americans has chronic sinusitis. If 5 people are selected at random, find the probability that exactly 3 will have chronic sinusitis. So I used the binomial distribution formula here, but you can use your calculator. Or you can use a binomial distribution calculator. So using calculator here, you will have the probability that x equals to x. So the probability that x equals to 3 is binomial. N here is 5, P here is 0.07, and x is 3. So the second question is probability that x is greater than or equal to 3. So we solve it by knowing either probability that x equals to 2, plus probability that x equals to 4, plus probability that x equals to 1. All we will do is 1 minus probability that x is less than 3, which is 1 minus probability that x is less than or equals to 2. And the probability that x is less than or equals to 2 is the binomial CDF of 5 and 0.07. So you can use either your calculator. You can also use the binomial distribution calculator. The mean here is NP. This is only for binomial distribution, NP. N is 5, P is 0.07. So the mean is 0.35. The variance is NPQ. Q is 1 minus P, which is 5 times 0.07 times 0.93 equals to 0.35 times 0.93 equals to 0.33. And the standard deviation, as usual, is the square root of the variance. Yes. You know that it's a binomial distribution because there are exactly 5 people, and each of them either has chronic sinusitis or does not have chronic sinusitis. So this is an illustration of the definition of a binomial experiment that we gave. You have a fixed number of trials. The probability of having is the probability of success. So in the binomial distribution, you have a fixed number of trials. Each trial has exactly 2 outcomes: success or failure. And the probability of success remains the same at each time. So X, the number of success, is the random variable. Hence, the number of people with chronic success. So generally, when you see me giving a number of people and give you the probability that a person will do something, most of the time it will end up being the binomial experiment. Just want to check that each individual, either that person has the characteristic in which the proportion was given, or that person does not have. If it works like that, it's the binomial distribution. Sometimes I will tell you that, okay, let X be a binomial distribution. Sometimes I will give you like this, but you can see from the problems I'm giving, that's where you are doing the technical. You will understand that some problems are actually a binomial distribution. We could do this problem just with in chapter 4. But in chapter 4, when I give you a problem like this, I ask 2 questions. Either all have chronic sinusitis, or none has chronic sinusitis, or at least one has chronic sinusitis. Okay? When I give that in chapter 4, that is how it is. But here it is not all, at least one, or none, which can be played around. It's 3 out of 5. So even if I have given you, let's say, 3 out of 10, you can work it with a binomial distribution. Let me look at the binomial calculator because you might see it as easier than, because I've already searched for it, it is easy for me to get. And the first one, binomial probability distribution, comes up. Here, the probability of success is 0.07. The number of trials is 5. And in the problem we have is a probability of being at least 3, exactly 3, less than 3, greater than 3. I will put that 3 here. It might just be for one question. This calculator will give me several answers. The first one is exactly 3. When you see equal to X, this is that X, 3. 0.0029, which we round up to 0.003. And here, at least 3 is this one, 0.00307. That is for at least 3. So that is what you can, how you can use a binomial distribution calculator. Any other question? So whenever you see a problem that has to do with exactly 3, at least 3, at least 2, think about a binomial distribution and begin to ask yourself, what is the number of trials? Is it given? Is it the probability of success? I left 2 other types of distribution which we could learn as well. The geometric distribution and the Poisson distribution, because I didn't want you to get so much confused with different types of distribution. As I told you, in a binomial distribution, X is the number of success. In a geometric distribution, X is the number of trials before you get the first success. Okay. So let's get back to chapter 7. If there is no question, if you have a question, You can ask. So your test will be next week, Thursday. Second problem is on Monday midnight. I will tolerate until before class. Let's say until noon. Just make sure you do it before that midnight Monday. If you have question, trouble doing some of the problems of technical problem 6, send me an email. Maybe it's on Monday, Wednesday, or Friday. Office hour is 3 to 4 p.m. Just go on Canvas, 3 office hours, and you will get it. You don't need to send me email because I don't want. I have a fixed link now. If it is Tuesday and Thursday, you just go to Zoom or you come to the class. So, I want to first summarize what we did last time. We read about confidence interval, the mean. Confidence interval for the mean. If the population is normally distributed, or the sample size is large enough, or the sample size is large enough. What we mean by large enough here is n is at least 30. Then, if sigma is known, the margin of error is if sigma is known, the margin of error is E equals to Z alpha over 2 times sigma divided by square root. If sigma is unknown, I don't want to say if sigma is known and then we work for so long. This second one, if sigma is unknown, we are going to do it next week Tuesday, but I want to write it now just for completion of my statement. If sigma is unknown, we use the T distribution. The T distribution with degree of freedom with degrees of freedom df equals to n minus 1. The margin of error is E equals to T alpha over 2. S is the sample standard deviation divided by square root of n. Now the question is, where do we get Z alpha over 2? Remember I told you last time, alpha is 1 minus the confidence level. Then alpha over 2 is the tail to the critical value Z alpha over 2. That number, you enter it into the inverse normal and you will get the value. But your PowerPoint has different values for. These are the values for the most common
confidence level you will get. If you don't want to use your calculator to go and solve it out, come and look. 90%, 1.645, 95%, 1.96, 99%, 2.58, 98%, 2.38, and so on. So once you have the margin of error E, confidence interval for the mean is sample mean minus E
So that's what you can see here in this much. That's the confidence interval. The book uses ZC, but I like Z alpha over 2 because it reminds you of where that value is coming from. It's the Z value so that the area to the left or the right of Z is alpha over 2. So we did this example. We did one example last time. Let's see if there is another example. Let's do the second example. Last time we computed the confidence interval for Julia running time when we had a record that for 90 days, and we have the standard deviation of the population sigma. Now we want to look at another case. This one is not. Okay, this example is about the sample size. How large a sample should we use to compute confidence interval within a certain range? So when the margin of error is given, for example, if I want you to get me the range of ages containing the average age of St. Francis University, as I said last time, if you come with 10 to 40, that is a range. It is correct, but it's not useful. I might tell you, I do not want you, once you get your point estimate, when you will compute your point estimate, I don't want you to be wrong by more than 1 year. So if you take your sample and take the average age, I do not want that point estimate that you got from your sample to be too different from the actual value by more than 1 year. That will mean that I am imposing the margin of error to you. Are we getting this? If I say, that is, if your average, if you come and tell me, sir, I got an average of a sample of 25 students, and the average is 18.5, then I should be sure that the actual average age should be between 17.5 and 19.5. Because I impose the margin of error. When you impose the margin of error, the other aspect that should change is the sample size. So when you impose the margin of error, that will mean that there should be a certain minimum sample size. Look at the margin of error. E equals to Z alpha over 2 times sigma divided by square root. This sigma will not change. It's the standard deviation of the population. You are not affecting, you cannot affect it. Z alpha over 2, you cannot affect it because you have a confidence level that will provide you. So if I give you this E, then square root of n will be Z alpha over 2 sigma over E. So n will be Z alpha over 2 sigma over E. So in some problems, you will be given sigma and a margin of error, and you are told what is the minimum sample size so that we are confident that our margin of error is not going to be too large. The larger the margin of error, the less useful the confidence interval is. So let's use this example.
A wildlife study is designed to find the mean weight of salmon caught by an Alaskan fishing company. The preliminary study of a random sample of 50 salmon showed that S equals to 2.15 pounds. So that is the sample that was obtained in some previous studies, not of what you want to do. In that case, it is assumed to be the population standard deviation, even though it is S. We say sample is for the sample you are working on. So understand that there is no way people will have the population standard deviation if they don't know the mean. So most of the time, the standard deviation that we use as the population standard deviation is the standard deviation of some samples that were studied in the past, which we want to use as an estimate of the standard deviation. How large a sample should be taken to be 99% confident that the sample mean extra is within 0.25 of the true mean of the weight of the salmon. What is this? I want to go and buy salmon for my business. And I ask you, what is the average size? What is the average size of the salmon from Alaska? And I said, you tell me, I can't get it until I buy some few of them to sample. And I said, okay, I am ready to invest in it, but can you give me the minimum number of salmon we should purchase so that I am 99% confident that when I get the average from that sample, I am not going to be wrong by more than 0.25. Do you feel what the question is about? Because if you buy less and it gives you an average and it is so far away from the average, you might be wrong in the business you are doing. So we do not want to exceed the actual value that we don't know by more than 0.2. So what is the minimum sample size? Minimum number of salmon that we should buy. So to do this, we will look at confidence level 90%, 99%. Z alpha over 2 for 99% is 2.58. The standard deviation is known to be 2.15. Those who have been fishing there have determined the standard deviation of the past of 2.15. So we do not want to exceed by more than 2 pounds. So the minimum sample size should be 2.58 times 2.15 divided by 0.2. So what do we get here using the calculation? help you understand why we are getting those numbers. For 99%, Z alpha over 2 or ZC is 2.58. For 95, 1.96. For 90, 1.645. Anybody has an answer for that end? 769.2. If we assume that in Alaska, they don't catch fish when they are selling, then we will buy 770. If you round this down, it will increase this margin of error. If you make 769, you will get less than what is required, meaning that it is going to reduce. You have done calculus, you know what dividing does. If you reduce this number, you will increase the margin of error. So don't round it down, round it up to the minimum possible number of individuals we can get from the sample. So we have covered 7.1. 7.2 is this part when sigma is unknown. We are going to use a different type of distribution, which is called the T distribution. It depends on degrees of freedom. We are still going to use calculator, but we will learn how to read their own table for this T alpha over 2. And then you can feel free to use. I don't want to rush much. That's why I want to stop here, because we still have to go slowly. We have exam next Thursday. So next Tuesday, we will do 7.2. We will go over take home problem 6, and then we will do 7.2. 7.2 is essentially the same thing. You still use your calculator. If you want to learn more, do the homework of 7.1. You can read if you want to go ahead and do you can even answer questions here without doing anything using your calculator, but you need to know what you are doing when you are using your calculator. Let me quickly take attendance. Brianna, Caroline was online. Julia, Sierra online. Ivan, Nicholas, Laura, Hayden, Grace, Jared, and Anthony, Kayla, Anna, Jordan. Okay.